Blood protein and nitrogen compound analysis experiment. In this chapter, you measure blood protein including total protein and albumin, as well as the blood nitrogen compounds. Total blood protein analysis. For total protein analysis, you receive 3 test tubes containing 0.1 milliliters of unknown serum, standard protein, and water. Fill 4 milliliters of Uric solution into the tubes of the unknown serum, the standard protein, and the water. Mix well with the vortex mixer and leave them stand in room temperature for 10 minutes. After that, pour the solution into cuvettes. Determine the absorbance in the unknown serum and the standard protein at the wavelength of 550 nanometers and set 0 with the water tube. Record the absorbance and calculate for the protein concentration from the standard absorbance value with 4 gram per deciliter in the concentration. Take a note of the result finally. Albumin determination in plasma. In case of albumin analysis, you receive 3 test tubes containing 0.1 milliliters of unknown serum, standard albumin, and water. Fill 4 milliliters of bromcrystalline or BCG solution into the tubes of unknown serum, the standard albumin, and the water. Mix well with the vortex mixer and let them stand in room temperature for 10 minutes. After that, pour the solution into cuvettes. Determine the absorbance in the unknown serum and the standard albumin at the wavelength of 630 nanometers and set 0 with the water tube. Record the absorbance and calculate for the albumin concentration from the standard absorbance value with 4 gram per deciliter in concentration and take a note of the result finally. Next, further calculate for the concentration of globulin using an equation that total protein is equal to the summation of albumin and globulin. Therefore, the globulin is equal to total protein minus its albumin. Finally, you can determine the ratio of albumin and globulin, so-called AG ratio. Determination of nitrogen compounds in blood. In this section, you determine the levels of nitrogen compounds, which is derived from urea, called blood urea nitrogen, known as BUN, and of uric acid. BUN determination. For BUN analysis, you receive 3 test tubes containing 0.02 milliliters of unknown plasma, standard urea nitrogen, and water. Fill 3 milliliters of oxime solution into the tubes of the unknown plasma, the standard, and the water. Then add 3 milliliters of acid solution into all the tubes. Mix well with the vortex mixer and boil all the tubes for 10 minutes. After that, leave them cooling down and pour the solution into cuvettes. Determine the absorbance in the unknown plasma and the standard albumin at the wavelength of 520 nanometer and set 0 with the water tube. Record the absorbance and calculate for BUN concentration from the standard absorbance value with 30 mg per deciliter in the concentration and take a note of the result finally. Uric acid determination. For the uric acid analysis, you receive 3 test tubes containing 2 milliliters of protein-free plasma unknown, standard uric acid, and water. Fill 0.5 milliliters of 10% sodium carbonate solution into the tubes of the protein-free plasma unknown, the standard, and the water. Then add 0.5 milliliters of phosphotungstic acid reagent into all the tubes. Mix well with the vortex mixer and let them stand in room temperature for 15 minutes. After that, pour the solution into cuvettes. That means the absorbance in the protein-free plasma are known, and the standard uric acid at the wavelength of 700 nanometer and set zero with the water too. Record the absorbance and calculate for the uric acid concentration from the standard absorbance value with 5 mg per deciliter in the concentration, and take a note of the results. Finally, take all the results from these experiment chapters into consideration, whether each value is higher, lower than, or in normal ranges. Finally, hypothesize whether all the results are the likelihood of which of the cases reported in your laboratory manual. That's all.